Hello, welcome to stream number 51 in this series where I'm programming an NES game live on Twitch from scratch. Let's get started. So, in the last episode, we were working on the asset tool, and we had basically made it so that you can now define a sprite which has collision points, and we had defined how to store off those collision points, which we now have here, so that we can today try and get the collision points loaded up to detect if we hit the background. Vince94, hey, thanks for joining the stream. And if we go back to the game for a moment, you'll recall that we now have the ability to, if I rewind a bit, fly through this level, and if you hit one of those bumpers, they will cause the ship to effectively crash. And the bumper here, if you look at the oh, you know what? The collision points button is overriding the... Oh, it just never went away. Interesting. So anyway, so we'll fix that in a minute. But the meta tile definition now has the ability to have a grid where you can toggle collision points. So that's what we were using for this bumper to say that this part here is collidable. So we got that code working, but now the problem is, of course, that we are hard coding the points that we are checking for collision. And the reason we were doing that was because we just wanted to get the code working that transformed the player's current position from the world position to the position in the map, where we then check to see if the player is flying over a collidable meta tile. And that's what this code is doing here. It's taking the player's X position and then mapping it for the screen, and then taking the Y position, the world position, and doing the same thing and converting it and checking if there's collisions, and then once it's done, we're good, either to mark the player as dead or to continue on with the game. So now what we have to do is we have to output the information about the collision data for the game to be able to read, because we're not doing that right now. I don't believe we are. When it comes to sprites, I believe we are only writing out the image as, so we're writing the char ROM information for the sprite, and then we are also writing assembly language code to generate the appropriate instructions to map the sprite that we have here as the sprite using the 8x8 hardware sprites for the NES. So now what we need to do is take the collision data and write that out. So let's see, what's going to be the best way to do that right now? One of the things that I want to do soon here is I want to be able to make it so that we can, with sprites, define what their size is and then allow for animation, because right now when you look at how we turn our images into sprites, we are basically doing a one-to-one. So we've got this PNG here, which then maps to this sprite, what we would potentially want to be able to do is, if we had something like when the player gets killed, there is an explosion that occurs. We need to have a sprite sheet, essentially, that would be probably the same 16 by 16 for the image itself, but then expand out, in terms of the number of frames of animation. And ideally what we probably want to do is, when we click on create sprite, it will ask for the dimensions of the sprite, and then we will provide the dimensions and allow it to display the sprite like this, assuming that the additional size of this PNG is actually for additional frames of animation, and warn us if it doesn't match, and then we can manipulate those frames, and the number of cycles we want the frame to appear, because animations aren't always at a fixed rate. It's not always, say 2 cycles per frame. It may be more or less depending on how the animation works. So we'll probably have to deal with that. But I don't have any artwork for that right now, so what I want to work on right now is getting these collision points to get stored out, and then we will figure out how to load them and check those collisions for the player, and then from there we can move on to animations for the next stream, I think. So what I'm kind of debating is, part of me wants to make the collision data be something that we load from a buffer, and part of me makes me think that we should maybe hard code it. I don't know. It's, I hate to do, because the Nintendo is so slow. There's always part of me that's kind of trying to be as efficient as possible, adding in some extra precautions in terms of the cycle usage that we have. But at the same time, you don't want to, there's that old saying that premature optimization is the root of all evil, or something like that. I think that's not exactly right, but the point is that optimizing for a problem before you know there's a problem can create all sorts of annoying problems that you didn't anticipate because you are trying to be clever. So maybe what I'll do for now is I will write a couple of things. One is, for all of the sprites that we load, I will write out an array that records the where's my pen? So what I'm thinking I want to do is I want to first write a buffer in out that has, for sprite 0, it's going to say, there are 0 collision points for sprite 2, there's 1 collision points for sprite 3, there's 2 collision points. But actually, now that I think about this, what else is going to collide with the background? There's the player. The player is going to collide with the background. Is anything else going to collide with the background? The bullets, I guess. I mean, we could create something that's really generic and would work for all cases, right? Where we could make something where all sprites arbitrarily have as many collision points as we want, but at the same point, like, do we need that? Do we actually care about that? Is that something that we want to be dealing with, or is it sufficient to just simply say the player has to have collision points, and so does the bullets? I don't know. I'm not going to have any of the enemies collide with the backgrounds, I don't think. Yeah, I think what I'll do is I will just store off the player collision points. Like, I don't know that we need to do any more than that. And we'll just store off, okay, here are the number of collision points, and then we just loop through them and check them, and then that should be it. So we're going to do just like this arbitrary designation that player is automatically the player sprite, and that's how we know which collision points we want to write out. I guess so. It's as good a way as any right now. Just hate to do it that way. Well, that's all right. So, yeah, so what we need to do is we need to... Pen's messing with the mouse here. All right. I guess what I want to do is make this a separate little piece of code and binary. So we can start by actually I'll do .inc to make it consistent. Okay, so so let's write out a label here. I'll just call it player collision. I knew there was an extra I in there, I just had it in the wrong place. Okay, so player collision, and then so that's going to generate our include for the collision binary, and then what is the syntax? I really hate the way that the syntax has gone in the Microsoft stuff with the standard sort of open and close nonsense. It used to be, I mean, and to be fair, I haven't done C programming in any modern context for work or otherwise in almost 7 years, I guess. Well, 6 years. So it's one of those things where and before that, even longer for a platform other than Windows. I used to do it more on Unix platforms like Solaris and AIX, but I just remember them being a lot more streamlined and not having all this decorative nonsense with the underscores, and I know that some of these are for safety purposes, but or security purposes, making sure that things are properly, allocated or assigned. But I don't know, they just seem super cumbersome. And I guess it's also coming from languages like C# and where some of it is handled a little bit more elegantly to some extent. I mean, there are obviously issues with C# too, don't get me wrong, but I don't know, seems like it's gone backwards to some extent. So player bin, player collision bin, and these damn flags. What are they? Oh, binary. Oh, create. Oh, write only. Oh, trunk. Let's open S. Where are you? Yeah, so. In C# but not much else. I've only just graduated from college, so I have a lot to learn. Yeah, I mean, C# is, especially from a workplace perspective, C# is a good programming language, you know, in terms of what it allows you to do. I certainly like it more than Java, but I don't know. I think there's just too much trust placed in those platforms for how they manage things for you, and the problem with that is then you end up with code that does things and you don't really know why or how, and you just kind of hope that it was done by somebody who knew what they were doing, and that it was written in a way that works under your specific set of circumstances. Not that the code you're working on is necessarily even that unique necessarily, but it's just like, I don't know. A lot of the concepts in C# nowadays are, you know, about you don't use threads, you use asynchronous unless you have to use threads, and you know, it all seems to work. I don't know if anybody has ever looked at, there's some articles I was looking at where they decompiled the CLR code to look at what gets generated when you do async, and it's crazy. It's just I mean, I guess it makes sense in some ways in terms of asynchronous programming, but at the same point it's like, how is that easier than threads? Because there's a lot more being done to manage these asynchronous implementations than I feel like is actually necessary for doing threads, where you're processing separate things in separate threads. And again, I know some of it is because you're dealing with situations where you're waiting for data to come back from an HTTP request or something like that, but I don't know. I mean, people have written multi-threaded code for a while. I think there are things that could have been done to make multi-threading work better without needing, you know, complex synchronization primitives, but nobody seemed to be focusing on that. Instead, they seem to be focusing on ways to make the code work without the threading, which seems foolish to me given how multi-threaded all systems are these days. Even low-end systems are, you know, dual-core systems at a minimum. Most of them are 4-core. Some of those cores are sometimes multi-thread. So seems like for high-performance stuff and work stuff, you probably would want something that performs really well. I can't think about what I'm trying to code while I'm trying to just talk about this. So let's see. So I want to write out the the size of the well, I want to write the current sprite, collision points size of current sprite collision points. And then, actually, how many, what is that? Is that number of collision points. And what is that? That's an unsigned short. Shoot, I guess I don't want it to be. Just for the ease of dealing with the NES. Oh, stop it. I know it doesn't take... Alright, so current sprite and collision points. This is an array, right? This is a pointer already. Size of vector 2 times current sprite dot collision points. Number of collisions, right? I mean, you know, you can have that argument all day long about what's more important, getting programmers to write their code more quickly or getting applications out as quickly as possible. Obviously, the answer is somewhere in between, but if you've never watched it, there's a great video by Mike Acton about data architecture and data-oriented design, and it's a great discussion about how programs can be written in a way that they're oriented towards the data that needs to be processed and written to be efficient using a language like C++, rather than being written in a way that it's efficient for the C++ programmer to write stuff, but the performance is garbage. So, oh, I needed to export that. And so you know, he was talking about a bunch of stuff. It's a really good talk. If you look it up on YouTube, you'll find it. He you know, he made a sort of an offhand joke about how Microsoft Office takes forever to open up because of this attitude towards performance and programmer comfort. Yeah, it's an interesting discussion. I mean, ultimately, I'm not saying that everybody needs to be writing the most efficient performant code ever, but at the same point, something we're working on at work is using a number of web frameworks. Well, that's obviously wrong. It's using a number of web frameworks, and yeah, so it's using a number of web frameworks, and oh, damn it, not doesn't equal 0, it does equal 0. It's using a number of web frameworks, including Angular and C# backends and stuff like that, and you know, it takes 15 minutes to compile on a machine with 16 gigs of RAM and a solid state drive. I mean, it's a freaking web app, right? Like, previous project I worked on had a million plus lines of code, huge user interface, did way more complicated things, and it took, you know, an hour to compile and run unit tests, you know. It's just completely crazy to me that this is like the acceptable way of things right now, that we're totally okay with this idea that we don't really care that it takes so long to compile things and and do this kind of stuff. That it's just, you know, that's the way it is, and we let the software handle it or the libraries handle it or whatever. Oh, is it because it's not using the extension? Okay. And I think that's going to continue until we get people who, or we find, actually I think realistically it's going to continue until we get to a point where it's harder and harder for hardware to get faster and faster, and you're going to end up where finally companies are going to start focusing on performance, because that's the only way they're going to be able to differentiate to make more money. Unfortunately, it's just one of those things where companies will go where the money is. So if customers start demanding that their application be faster because they can't buy more hardware that's going to make it perform better, then, you know, that's where we're going to be. So this is actually, so this works except for the problem that these are not. This vector 2 is 16-bit, so what we'll do, let me think about this. What am I using vector 2 for? I'm using it for stuff within the user interface where it makes sense that it would need to be (16 bits), but for the sprites and metatiles, actually doesn't need to be. So let's do this. I'm gonna make a new vector 2 specifically to be bite-sized, but joking aside, where it's actually using bytes instead of shorts, because it doesn't make sense to store them as shorts because we're never going to need them as shorts. 16 bits for our sprites and metatiles, and so we're better off just having these be bytes so that we don't have to do any conversion. We do use them in the GUI code, which means that we still need the original type, but we will fix these here. So this can be that, and then that's our collision points. Yep, that's good. It just occurred to me that we could have done an assignment between vector and vector here, but now that they're vector and vector 2b, it doesn't matter. It ended up being the right thing to do. So, all right, so well, then so that we don't need to do this, right? We just write it out as the full array. because looking at the hex editor, what I was seeing is I was seeing 0, 7, 0, 1, 9. No, what is it? 10, 11, 12, 12, 14. So we had all of these double byte values. We don't want it to be 2 bytes for the collisions. We want it to be a single byte. What's wrong with this now? Sprite selected, bounding box. Yeah, this should be a vector 2b. And then let's see what else breaks. That was it. That wasn't so bad. Okay. So let's resave the sprite here. Flip the background color. Save it. Where's the bullet? Sprite. Let's fix this. Create sprite. That's good. Background is good. Create the sprite. Flip the background color. Save it. Alright, so the meta tiles don't have to change. This one needs to be recreated. Create sprite. Okay, that's fine. And those don't even matter for what we're doing. I just wanted to have them be correct for what we were doing here with the sprite for the player. So we got that collision point, and that one. So let's save it and export. We go back to the hex editor and reopen this. It's shorter. So we have 1, 2, 3. That doesn't seem right either. Number of collision points should just be 3, which it is. And then we have, how many bytes is this? 9 bytes. Why 9 bytes? Number of collisions, collision points, number of collisions times vector 2b. That should just be 6 bytes. Export that out again. So number of, let's see, that's collision points. Oh, wait a minute. So that should be that, and then this should be number of collision points times vector. Okay, I think that's why. I think we had an extra. We had some extra information being written. So let's export that. Six. Okay, so that is good. So we have our player character, player collision bin. Where is the ink? What did we call it? Player collision ink. So we need to bring these over to the game folder. Include player collision.ink. All right, so that built. Now what we need to do is we need to take a look at, let's take a look at that file. So that's the label, and that's the data. So what we would want to do is Well, you know, see, here's the thing, right? Like if the player collision points isn't going to change, so it's kind of dumb that we're going to be checking the size and looping through every time. I mean, unless we were. I don't know. I feel like it's somewhat counterintuitive what I'm doing here, just because I'm trying to determine what's the best way to do this efficiently. But let's just do what we've got here, and then we'll mess with this as we need to. So what I think we're going to need to do we use Y for anything? We're not using it, so we're going to use, well, we do, but we're going to use it for our counter check. So what we want to do is we want to say load Y 0 over here, and then what we'll need to do in the section here where we're doing our collision checks, we will want to, but A has something in it. We're using temp and temp word. We're not using temp2, so let's do that. Let's load Y with 0 and store Y into temp2. This is our counter for the collision loop. So we want to load A with the position, and then we want to increment the X position with the first of the possible collision points that we're dealing with. So we know that there will be 3, assuming we are doing this. Okay, so let's do this. So temp2 has our bear with me here. I'm pretty sure I remember that you can do, where's the one that I used? This one. I reset my browser settings, and so the autocomplete left me here. Yeah, this is the one. Arithmetic shift left. I think you can do this with an address. Yeah. Okay. So the one thing I still don't like about working in assembly sometimes is all the juggling that you have to do between the registers and memory. I mean, you don't think about it when you're programming in higher level languages, but man, do you ever think about it when you're programming in assembler. So that is that, and then we want to store that into temp3. This is used for shifting into the appropriate position in the collision buffer. Temp 3. So we multiply that by 2 by shifting it left one time. And that's going to give us our offset into the collision buffer that we wrote out in that binary file. And then what we want to do is we want to load A with the X position. And then we want to load Y with temp3. And we want to then clear the carry and add carry, player collision, right? Is that what it's called? It's all caps. Player collision, comma Y. We got to increment that by 1. Can you just do that? Oh, actually, we can just increment Y. We have to increment by 1 because we have the index of the number of collisions at the first byte, so it's always going to be off by that 1. So we do the clear, and then we add carry player collision, comma Y. So that gives us our X position, the X position for the first collision point, assuming Y is, or assuming that we're at the first collision point that we're looking at. Right, so we don't need to do that there. Right, that was, yeah. So it gets the, we know that that's going to be within a reasonable range where it's not going to create any sort of problem because the X is going to be between, it's going to be the within the bounds of the screen. So then we do that, we take care of that, and now we're dealing with the Y position here. And similarly, we want to load A with, well, after it does, well, what is that? That's loading the A value. We want to load Y with temp3. We want to increment it twice because first we want to increment for the offset, the first byte that has the number of collision points that's at the beginning of the buffer, and then we want to increment 1 byte past the X byte that's stored, right? Because we're, for our collisions, we are, the format is, I have the pen upside down. The format is, we have our number of collision points, then we have X, Y, X, Y, etc. Right? Right. So, okay. So that should then allow us to clear the carry and add carry player collision with the Y register offset, and that would give us our lower position. And unfortunately, we want to check the carry. Well, do we care about that right now? I guess not. Maybe we. We probably do. I hate to put it off in case we do. All right, so branch carry clear to the next label. What we would want to do then here is well, actually, this is irrelevant. I don't think this is going to be affecting the carry flag. So what we would want to do here is we would just want to say we want to increment if the carry is set. Otherwise, we don't need to increment. And that's because this is the upper byte of the 2-byte value for the world position. Damn it, is there no way to increment A? I always forget that. You can't just do this? Urgh. Why? It would make my life much easier sometimes. Clear carry, I'd carry 1. Okay. So that's that. So that would be what we can do for our check here is let's make sure this works as is with the first collision point, which is right at the nose of the ship. Okay, so we still collided, which is good. And now it looks like we're not colliding where we did before. Oh, well, that was questionable where we were. Is it not working? I don't know. Should change the map so that it's easier to test these collisions and just have like have it lined up with where the ship is going to be so I don't have to get into position. It looks like it's not exactly right. So first of all, let's just double check here before anything. So the first thing, it's going to be offset the X position by 7 and the Y position by 0, so that makes sense. Let's go into the debugger and take a look here. Okay, so check for collision. Okay, so this is the breakpoint that we want. Okay, let's test this out. So that's the X position loaded into A now, and we're going to look at, let's see, what's temp 3? Temp 3 is 0. Temp 2 is 0, which makes sense because this is the first time through the collision loop. So we're going to increment Y, and that's our first position. So we're going to clear the carry, and we're going to add, it should add 7. Okay, good. So it did. So now it's doing its calculation, and then storing that into temp. So that looked right. That gave us the right value. And then let's see. So now we are setting up adder param 1. We're getting the Y world position. We're loading Y with temp 3. We're doing the double increment. We're clearing. And so that A should be unaffected. It should still be 7. 7. Oh, because, okay, yeah, that's possible because this might be entity Y pos. So it would be 7. What is A set to? C7. C07. Yeah, that's right, because the map is 32 times 32 times 100 rows. subtracted some rows from it. Okay, yeah, CO7 looks right. So that that all looks good. Yeah, so Messin, this emulator is ridiculously good. The person who develops it, Sour, is not only super on top of everything, but this emulator is not only it's just so good. Everything about the way that it works is so easy to use, and it just really makes NES programming so much easier. And from what I've heard, if you have feature requests, he tends to get them done pretty quickly. Am I just kind of hitting the collisions? No, it still seems to be. Was there a bug in the way I was calculating this that I wasn't aware of? Because the let's do this a little bit slower so we can actually see what's going on here. Oh, you know what? I wonder if the collision, I wonder if the metatile data that I am using right now is not up to date, and it's using. I had made a change to the way the bumper had its collision data written out, and it was because I was testing out some additional. I was testing out to see, or I was actually demonstrating a point, which was how bad collision can sometimes make a game unplayable or annoying, because of the fact that you collide in a place where it looks like you shouldn't, and so your assets kind of have to work around the limitations of the way your collision works, or you end up with an annoying, buggy looking game. And so I had extended the range of the collision for the bumper. I wonder if that's the version I'm using right now, or I was using up until a moment ago. It seems like I am, but let's see. Should just hate to. I'm a little nervous to just redump all the attributes into the folder, but at the same point, it should work. So this is all of the redumped stuff from the export. Let's put this into the shooter folder, replace, and then rebuild. And restart, and fingers crossed that nothing broke. Okay, well, that's a good start. Okay, yeah, that seems to have fixed it. Okay, so as you can see, it's not colliding now with the it's not recognizing my controller presses. Why? Oh, I remember. Okay, so we had made a slight hack to this because I forgot about that. So there was a slight little manual modification we made for this, because right now this has no idea about the player states. So I had to just manually put this in. Let's see. Data, I believe it's in data. Yep. Oops. So yeah, it doesn't understand the sprite states right now, which is why the sprite wasn't disappearing. So now is okay. So let's see. Now it seems like it's still off. I guess the real question is, wow, why is that so far off? Let's take a look at the bumper meta tile here and the grid. So this part should be safe, and the player sprite collision point is the corner. 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that looks right. So let's see. Why would this be a problem? I mean, it's loading at least the initial value correctly. We haven't put the loop in yet to check the other collision points, which is fine. So the only real modification we made at this point is handling the X and Y offset for the first collision point, which should give us a similar result to what we had before, but seems to be yielding slightly different results. So that is okay. That's not. Why was that considered a collision? Unless it's really, like I said, unless there's some legitimate bug with the way that we're doing that calculation. So how would that be? You know what we can even do? Well, I was going to say we could change the way that the map is written out, but I don't know that I want to do that. Let's go back into the debugger here for a second and kind of step through this whole process again. So first time through, like I said, I think this is all right. So we're going to get 87. So if we figure that out, so 87 divided by 32. Oh wait a minute, it's not 87, it's 87 hex. So 135 divided by 32 gives us 4. And player starts out. Let's get this drawing here. So the player starts out in the map, like right about there. Yeah, right about there. No, that would be right there, because there's that meta tile right there, right? So there's the player. And the player's position kind of central to that should be yielding us a position in the X of 0, 1, 2, 3, 4. That's fine. So if we do that calculation here, we get 4. So that's as expected. Oh, I know what the problem is. It is when we do the fine. Did I forget to? Yeah. So in addition to the coarse collision detection we're doing, we also do fine grained collision detection here. And yeah, I'm not doing it right now, so it's just using the straight up X and Y coordinates that it had before. Oops. All right, so same thing, same deal here. We're going to clear the carry. All right, we're going to load y first with temp3. We're going to clear the increment it. Then we're going to clear the carry. We're going to add carry. No. Yes, we're going to add carry. Player collision y. So y was just for this lookup of the meta tile, so that's good. We can do that here again. So that gives us that. And then for the, let's see. So add a param. Temp holds our offset into the meta tile. Right, it does. Compare 8, branch carry, set clear, subtract 8. Collision +1. Oh, right. Okay. Right. So basically what it is that I had forgotten. So we only care about the X at this point because basically we're at the position, we have the meta tile that we need, which gives us our Y. We have, I think, the player's Y position already determined, being shifted by oh no, that's here. Never mind what I just said. We still need to do that for the Y position. I don't know why I was confused here. Yep, so we have this. We want to load Y with temp3. Same deal as before, right? We want to increment Y twice. We want to load clear carry and add with carry. Player collision Y. Store it. We'll load this. Same thing here. Branch carry clear to the next label. Otherwise, we're going to add 1 to A because we've went from 255 to 0, which meant that the carry overflowed. Oh, let's see if this is fixed. So there's supposedly a way that you can, in here, just write some basic code. So if you do, let's see, so if you load A with, let's say 255, right? And then you clear the carry and add carry 255. We should get the carry set. So what we would want to do is then we want to load, I want to make sure that loading this with the value doesn't kill the carry flag. I don't think it does. Branch carry clear to this here, which will make load A with 10. Otherwise, we go there. So, oh, it doesn't like that. Branch carry clear to A, and this is A. Branch carry clear. Huh? That should be okay. What doesn't it like about my label? What syntax? Labels can be used. Okay. That's, oh, because it's A, and that's a register name. Never mind. A. So we'll change that to M. Okay, so execute that. The CPU will not resume until a write to 3000 is formed. This will assemble and execute the code. Execute, yeah. So then load A and store with 0 and store it to 3000. go to the debugger, go to 3000, and apply. Content currently on CPU. Okay. Guess I need to read up on how that works exactly. All right. That's just purely my own ignorance. I'm sure that it will work. Meanwhile, there's this, which actually works well too. So load A. Oh, did I lose all my code by doing this though? Damn it. All right. Let's reset the game. Like I said, I just want to check that by loading A with a new value, it doesn't reset the carry. Load A. Clear carry, add carry 1. Load A 5. Branch carry clear to M. Otherwise, load it with 10. M is here. So if it works like I expect, we'll have 5. If it doesn't, we'll have A. Oh no, wait. Branch carry set. No. Branch carry clear. The carry is supposed to be set. What am I testing? I'm testing that the carry is still set. So I want it to be right. I want it to stay 5 because the carry is set, which it is, and it continues to be. All right. So that looks right. So that should be correct what we did here then with this. Okay. Sorry, that was just... I thought that was the way it worked, that it didn't mess with the carry flag when you do the store like that, but or the load, but I didn't know for sure. So I think this will fix it now, because now we're actually doing the lookup of the individual subtile. Yeah, okay, cool. So now that collision worked as expected, but now if I do this, it should collide. Oh crap, why didn't it collide? Is it using Y over here? It is. Damn it. Okay. Not a huge deal. So let's do this. Let's transfer Y to A and push A. And then once we're done with all of this stuff, we can pull A and transfer A to Y, and then we have our Y value back, because we need the Y here for the indexing into player collision, but then we need it back to the original value for this to be able to get the MT collisions +1 value correctly. So we pushed it onto the stack and then pulled it back off the stack. So that should be okay. Let's see if that fixes it now. I forgot that we needed the Y value. I need to speed this up a little bit. Okay, so that seemed correct. That, yes, that was what I wanted to have happen. So emulation speed back to normal. So now it looks like the player is properly colliding with the tip of the ship and not the corner. All right, so now what we want to do, awesome. So now what we want to do is we want to get the other collision points tested as well. So this is our collision loop here. what we can do is load y temp2. I realize that's wasteful to store it and then load it again, but it's just because of the way we're doing this in the loop. I don't know if it could be whatever. It's just one extra op. We don't care about it right now. I don't care about it right now. So, all right, so we're at this point here. Let's see. So let's see where we are, where we're not. We think there's no collision. So we've done... Let's see. Where is it? So this is our coarse collision detection. So if branch equal, this should not be going to here. It should be going compare it to 0. Load A, clear carry, or A, compare it to 0, branch if equal to, that looks like a mistake. Let's say check collision loop here. Because if it's 0, then we're done checking that meta tile for that particular point. So that's entity complete, which we don't want to do yet. So check collision loop is here. So now at this point, the only thing we care about as far as the registers go is the X, because X is still being used to increment through the entities. So what we want to do is we want to increment, oops, not there. We want to increment temp2. Temp2. Load a player collision. Load that, compare it to temp2, branch if not equal to, I think it was just collision loop, right? So increment temp2 to the next index, load A, no, this is load Y with 0, and then get the player collision point count, compare the player collision, player collision point count to temp2's value, and branch if it's not equal to collision loop, which brings us back to here, which then takes temp2 into Y and stores it into temp3 and shifts it by 2. I figured that branch was not going to work because it seemed like it was too far. So branch if equal to this, otherwise jump to collision loop. This is gone and this is this. So now in theory we should be checking all of the collision points. One, two, three, 1, 2, 3, 1, 2, 3. Okay, so that looks okay. That looks correct. So let's see if now, as we fly, the wings will collide kind of as expected. Yeah, that did. At least based on what I was expecting it to do. Let's we'll slow down the emulation a little bit and try and get a little more coarse with it. I mean, fine-grained rather. Yeah, that looked more or less like what I expected. So we hit the tip of the wing on the right-hand side, and sure enough, it killed the player sprite. Now, it's still not 100%, and that's not because of the collision detection. That's because of the way that the meta tile is laid out with the collision on it. It looks like it's pretty darn close to, if not exactly as expected. So I'm reasonably happy about that. Like I said, you know, we part of the issue is that, you know, I made this artwork, as I'm sure you could probably have guessed. And the way that it's lining up, it's the border of that bumper is not 8 by 8 aligned. So what you end up with is you end up with this collision area here being, I don't know why it does that sometimes. It like doesn't properly register. So anyway, so you have this little bit of the bumper that overhangs the collision boundary, and realistically you want to make it sort of match as closely to the meta tile as possible, or not even that, you want it to match as closely as possible to the 8 by 8 grid. That's kind of the nice thing about the way that this is working now, is that it is 8 by 8 tile collision, but we've optimized it in a certain sense because we are not always looking at every meta tile or every individual tile, and in fact our map isn't stored by, if you'll recall, it's not just a raw 8 by 8. Sorry, it's not a raw map where we're using only the 8 by 8 tiles that the NES supports. These meta tiles are 32 by 32, but because of the way we've built the collision now, we are able to broadly check, okay, is this 32 by 32, does it have anything collidable? Does this have anything collidable? Does that have anything collidable? Does that have anything collidable, right? And as we pass over something that has collidable tiles within it, like we could have a meta tile where, you know, you only have that one inner tile that's collidable, which gives us a lot of flexibility to build the game in such a way that, you know, we don't have to worry about having these bogus collisions. Hopefully, that's the idea anyway. And so I'm excited that that works. Like I said before, we may have to go back. I mean, right now we're looping through the player's collision data. We don't have any of the other sprites having any collision data for the map, but I don't think we care about that. I think what we more care about now is the bounding boxes, and going through the process of getting these sprites to have bounding boxes that are reasonable. Right now these control points for clicking don't actually work, so that'll be another thing we have to do, is make it so you can actually resize those bounding boxes in the asset tool, because you can change them in the file and they totally work, but it'd be nice to make that part work. And then, like I said, the other thing is that we need to start adding in things like animation. We need to also be able to start adding in things like the sprites should recognize changes of state. So for example, something in here where if you click on a sprite, you can enumerate a set of states and whether or not the sprite should be drawn based on that state. And then I wouldn't have to go into this code and actually do that check myself here, right? I mean, the one thing that's nice about me doing this here, and maybe we can generate that too. Maybe we can generate that enumeration in the asset tool, because then it would actually have this rather than just saying, compare to 1, which is harder to read and harder to debug in the end, to some extent. So I think I'm going to leave it there. I know these last 2 streams have been shorter than my usual ones, but I also feel like the shorter streams are better for everybody, so that they're not going to have to, for people who are watching the recordings, they don't have to go back and watch a 3-hour recording. But let me know what you think on Twitter at Clarivis, on Nintendo Age. I'm in the Discord pretty frequently. Comment on the recording on the video on YouTube. I will post this on the recording on Twitter when it's done uploading. But thanks for watching, and I will see you on Thursday at 9 p.m. Eastern. Take care.